Hello everyone, my name is Haiyang. I'm from the Department of Economics, University of Connecticut. My topic today is to introduce how to build a movie recommender system in Python. So first, what is a recommender system? A recommender system is an information filtering system which recommends the products or items to the user. In our daily life, we have come across a lot of examples of it. For example, Facebook might show you people you may know, YouTube might show you a list of recommended videos for you, eBay might show you items based on your browsing history, and Amazon might show you that customers who bought this item also bought. Usually you will find those recommendations are pretty useful. So, how do they work? And the answer is, by drawing from huge datasets, the system's algorithm can find accurate user preference. And once you know what your users like, you can recommend them new and relevant content. And why is this so important? A recent Epsilon research indicates that 80% of consumers are more likely to do business with a company if it offers personalized experience. And based on report from McKinsey in 2013, recommendation engines has generated around 35% of Amazon's revenue and 75% of what people watch on Netflix in that year. And in recent years, it just becomes more and more important. In this presentation, I will introduce two basic types of recommender systems. The first one is called Content-Based Recommender System, and the second one is called the Collaborative Filtering Recommender System. So let's look at the first one, Content-Based Recommender System. In this method, the similarity of items is measured based on the characteristics of items being compared. And after that, the system will make recommendations based on the content of each item. For example, if a consumer has bought a black shirt with color and a dark gray shirt with color, the next time when the consumer logs back into the shopping website, the website is highly likely to recommend a light gray shirt with color instead of blue shirt without color to that consumer, because the blue shirt without color is less similar to the two shirts that the consumer has bought. So the advantage of this method is, if the item has sufficient descriptions, it will be recommended even if no one has ever consumed the item before. But it also has a lot of limitations, and the first one is the data availability. Sometimes the content is not available. And the second problem is, this method will recommend items similar to those already consumed, with a tendency of creating a filter bubble. And the third problem is precision. The methods based on collaborative filtering has been shown to be empirically more precise when generating recommendations. So let's look at the second method, collaborative filtering recommender system. In this presentation, I mainly focus on the memory-based collaborative filtering recommender system instead of a model-based collaborative filtering recommender system. This method uses the entire database to analyze similarity between users or items, and once the system identifies similarities, it serves users recommendations. So this method has two different approaches. The first approach is called the user-based collaborative filtering, and in this approach, the similarity of users is measured based on the user's reading history. The second approach is called item-based collaborative filtering, and in this approach, the similarity of items is measured based on the user's reading history. We can simply show the difference between the two approaches by using one example. This is a movie rating table, and this table consists of 5 movies and 5 persons. So within the table, minus means the person didn't like the movie, and plus means the person liked the movie. So we have several blanks left. So if we want to ask the question whether Nayana will like the movie Superman, we can simply use the first approach, user-based collaborative filtering system. And in this approach, we are comparing Nayana with other users. And in this case, we can see that the reading history of Nayana is identical to the reading history of Vidya. And because Vidya liked the movie Superman, so we would expect Nayana will also like the movie Superman. We can also use the second approach, which is item-based collaborative filtering, we are actually comparing the rating of Superman with the rating of the other movies. And in this case, we can find the rating of Superman is identical to the rating of Papillon. And because Nayana liked the movie Papillon, so we would expect Nayana will also like the movie Superman. The advantage of this method is, compared to the content-based method, it is more accurate. And the limitations of this method include, first, collaborative filtering system needs a lot of data to create relative suggestions. And the second problem is called the cold start problem. New users will have no to little information about them to be compared with other users, and similarly, new items will be in lack of ratings to create a solid ranking. Now let's try to build a movie recommender system using a real-world dataset. The dataset I'm using is Movie Lens. It has 100,000 ratings from 943 users on 1,682 movies. Each user has rated at least 20 movies, and the data is collected by the Group Lens research project at the University of Minnesota. It is released in April 1998. The data can be downloaded from the following website. Next, let's start from a content-based recommender system. In a content-based recommender system, we need to calculate the similarity of items based on their characteristics or their content. So we need to first get the features of each movie. In this context, we can see the features of each movie includes the movie ID, movie title, the release date, and their website, and also 19 different genres. Those features of each movie will be stored in the table items. The next step is to clean the data. Because movie ID, movie title, the release date, and the website is not likely to affect people's rating of it, so we just need to keep the 19 different genres of each movie, and the cleaned data is stored in the table items new. Next part is to calculate the similarity between different movies. Here I use the cosine similarity as a measure of similarities. Here I'm treating the features of each movie as a vector. By using the cosine similarity function, I'm actually calculating the angle between two vectors. The logic is, the smaller the angle is, the more similar the two vectors are. So, the similarity is maximal if the angle is 0, meaning the two vectors point in the same direction. The similarity is 0 if the angle is 90 degrees, when the two vectors are orthogonal. The table at the bottom of this page showed us the similarity between different movies. To make the table more friendly to readers, I use a dictionary to replace the movie ID with movie titles. The next step is to show the 5 most similar movies for each movie. But before that, we need to realize the cosine similarity between a movie and itself is always 1, the highest number. And it makes no sense to show a movie's most similar movie is itself. So we need to adjust the cosine similarity matrix before we move on. Here I'm replacing the cosine similarity between each movie and itself by 2, a number greater than 1. In this way, we have made the movie itself as the most similar movie. So if we need to show the 5 most similar movies, we can get rid of the movie itself by simply taking the second most similar movie to the 6th most similar movie. In my code, the first 2 rows realize the adjustment that I just mentioned. Then I create an empty data frame with 1,682 rows and 5 columns to store my result. And then I use a loop to find the second to the 6th highest similarity of each movie and store their index or their movie titles to the empty data frame. The final result is displayed at the bottom of this page. Now let's try the more accurate method, collaborative filtering recommender system. We start from the easier item-based method. Generally, we are still comparing the similarities between different movies, but instead of using the 19 different genres as the movie's features, we are using the user's ratings as the features. Since we have 100,000 ratings, the result generated with this method should be more reliable than the content-based recommender system. So we first read the data and store them in data frames. The ratings data frame has the ratings information that we need, and the user's items data frame has the information of users and movies respectively. To construct the similarity matrix, we need to first use the pivot table function to transfer the 100,000 by 4 ratings data frame to a 943 by 1682 data frame, with each row represents a user and each column represents a movie. So movies features are stored in columns. And to avoid problems in calculation, I used the number 0 to replace any missing readings. The feature matrix is stored in a data frame named rtable. Next, we use cosine similarity function to calculate the similarity between different movies. Because movies features are stored in columns, I use rtable values transpose as the argument in the parentheses. The similarity matrix is stored in the data frame named SIMDF. And again, I use a dictionary to replace movie ID with movie titles and create an empty data frame to store my final results. Similarly, I use a loop to identify the second to the sixth most similar movies because a movie's most similar movie always ranks in the first place. The results are displayed at the bottom of this page, and we can notice that they are quite different from the results generated by the content-based recommender system. The last method I'm going to talk about is the user-based collaborative filtering recommender system. This method can be split into two parts. The first part is to find the most similar users for each user based on their movie taste. It is very similar to what we have done in the two former methods. The second part is to recommend movies to each user based on their most similar users' rating history. As always, we need to read the data and store them in data frames. And again, users' information is stored in the data frame users, movies information is stored in the data frame items, and rating history is stored in the data frame ratings. Then I use the pivot table function to transfer the rating data frame to a 943 by 1682 data frame. Again, each row represents a user and each column represents a movie. Now I want to use the cosine similarity function to calculate the similarities between different users. And because users' features are stored in rows, so I just used rtable values as the argument in the parentheses. And the similarities between different users is stored in the data frame SIMDF, which is displayed at the bottom of this page. Using the same method, we can get the 5 most similar users for each user, and the next job is to recommend movies for each user based on his or her most similar user's rating history. The method I use to measure the popularity of a movie among the 5 most similar users is I first calculate the weighted sum of the 5 most similar users' ratings for each movie. And since I do not want to recommend movies that the user has seen, so I change the weighted sum ratings to 0 for those movies. At last, the weighted sum of rating is not a good measure because a movie with only 1 rating of 5 and another movie with 5 rating of 1, they all add up to 5, but you do not want to recommend the second movie. So I take the total number of users rated into account by dividing the weighted sum ratings by the weighted sum of total numbers of users rated. In the adjusted rtable, I keep all 0 and I replace all existing ratings with 1. This data frame will be used to calculate the weighted sum of total number of users rated. In the not seen movie rtable, I replace all existing ratings to 0 and all 0 to 1. This will be used to change the weighted rating of the movies the user has seen to 0, so those movies will not be recommended to the user. Since the calculation is complicated, here I just want to recommend 6 movies for the first 10 users. For each one of the 10 users, I first get the ID of the 5 most similar users, and I get their similarities. After that, I use those similarities as weights to calculate the weighted sum ratings for all movies, and I change the weighted ratings of those movies the user has seen to 0 with the help of the not seen movie art table. Next, I calculate the weighted total number of users rated with the help of the adjusted art table. And the predicted ratings for all movies are calculated by using the weighted sum ratings divided by the weighted total number of users rated. At the end, I can simply select the 6 movies with the highest predicted ratings and recommend to the user. The results are displayed on this page. And as we can see, although this method is the most complicated one, it also provides the most personalized recommendation, and it is a very powerful tool. And this is my presentation today. Thank you for listening.